Bismillahirrahmanirrahim. We talked about some of the features that need to be supported in the network in order for our network to be efficient and scalable for communication. So we talked about, or we touched a little bit on the concept of fault tolerance and scalability, and we talked a little bit about quality of service and security. So we'll cover these concepts in more details now. So again, fault tolerance talks about the fact that my network needs to be tolerable to faults, which means that if there is any problem in my network, if one of these links goes down or one of the network devices goes down, my network should be flexible enough to minimize the interrupt caused by this fault. Okay? So that's what fault tolerance is all about. So even though it's a fault, but I need to minimize the impact of that fault. The less the interrupt due to this fault, the more fault tolerant my network will be. That's what this means, okay? So there are two types of communication paradigms that exist in the network. One of them is what we call circuit switched networks. By circuit switched networks, we mean that before we exchange information, we need to establish the end-to-end communication. This happens, for example, for the landline calls. So when you try to call someone on the other side, what you do is that you dial the number. And what this will do is that it will send a request to the network, and the network will create this whole circuit for your call. Okay? So the network establishes an end-to-end physical circuit to serve your communication. What is the implication of this? Well, the network has to spend some time to establish this circuit for you. And the other thing is that this circuit is going to be dedicated for your call, even if you're not using it. So imagine if you are calling someone and you left the phone and you went away, well, the circuit is there. It's consumed. You're consuming the network because it's dedicated for your call. That's why for your call you get charged by the time, not by the amount of information, like in the case of data, when we exchange data over the internet. Voice calls, you get charged by the time. Why? Because even if you're not using it, you're still consuming the circuit. So it makes sense. But for data exchange, you get charged by the amount of information, which is what we'll talk about in the next slide. So circuit switch, what does this have to do with fault tolerance? Well, it has some implication on the level of fault tolerance that you can support in your network. Because if we're talking about circuit switched, if you have any disruption in the voice call, what will happen? The call will get disconnected. And you have to dial the number again. So here the interrupt is significant. Why? Because the circuit is again dedicated for you. If there is any problem throughout the line, you have to re-establish the communication from the beginning. Because the whole communication is disconnected, is dead. And you have to re-establish, which means that you have to spend some time to re-establish the communication again. That's a significant impact. So circuit switched is generally less fault tolerant compared to the paradigm that we will talk about in the next slide. Okay? The other type of networks is what we call packet switch networks. We use this type for data communication, whether on Wi-Fi, Ethernet, cellular communication. So recent network technologies, they use the concept of packet switched or packet switching. What does that mean? This means that my communication will be divided into smaller pieces of information. Each piece of information will take a different path, a different route. I don't establish any circuit. There's no dedicated circuit for your communication anymore. And instead, your information will be divided into smaller pieces, and then these smaller pieces can flow in the network in any undeterministic path. And they may arrive here unordered, right? Because if you imagine multiple people are going from their houses or from one house to the university, but they take different routes, they may not arrive in the same order that they started, right? So there's no guarantee on the order of the information, in which case we have to make sure that we reorder the information once it arrives to the receiver. That's the disadvantage. Versus for circuit switched, everything is going through the same route, through the same pipe, if you will, in which case they will arrive in order. Not only that, they will take the same delay, more or less, right? So delay is deterministic. They go through the same route, they arrive in order. That's the good thing about circuit switched. But as a cost you pay is that the circuit is fully dedicated even if you're not using it. So that's not efficient. Here, for packet switch, there is no established circuit, and we can tailor the resources of our network per packet. So the granularity is much more. So I can have ultimate flexibility in assigning the network resources to the different communications that are happening on the packet level as opposed to on the end-to-end communication level and established circuits. So maybe you didn't live these days, but in the past, sometimes on the telephone lines, we try to dial a phone number and then you get a message, all circuits are busy now, please dial again later. So what does that mean? This means that all my switches are being consumed because I have to dedicate these switches to the different calls, and these switches have limited capacity. So even maybe these people are not talking over the phone, they are not using actually, but they are consuming the network. And I have no way of figuring out whether they are using it efficiently or not. But my network is fully consumed. Here, if you're not sending any information through the network, you're not consuming any resources. Which means that we consume resources in the network only if we send these packets. So this way, the capacity of the network is used much more efficiently. Okay? The implication of this is that they may take different routes, they may take different paths, in which case they arrive unordered. So that's the advantage and disadvantage of each one. But this is the trend. This is the much more efficient way, because this allows the network designer to use the capacity of the network in a more efficient way. And that's a very critical issue. Okay? We talked about scalability. We said that scalability means that I can expand my number of users without affecting the performance of the existing ones. So how we can make this happen in the internet? The way that we make this happen on the internet is by having what we call a hierarchical architecture. So the internet has hierarchical architecture, in which case we have the internet divided into tiers. So there is tier 1 service providers. Tier 1 service providers are very few on the internet. So we have AT&T, Verizon, few other service providers. That's it. These tier 1 service providers, they have huge infrastructure, which is really, really sophisticated. They use fiber optics to connect all routers together. The routers are extremely high speed. And this infrastructure, they offer it as a service to tier 2 service providers. Tier 2 service providers like Ooredoo, like Vodafone, these service providers, they have a little bit less complicated infrastructure. They don't support the amount of traffic like the tier 1 service providers. And again, they use their infrastructure to offer it as a service to what we call local service providers. Local service providers like QU. QU is considered a local service provider. Again, they have a fairly sophisticated infrastructure, right? And they offer this infrastructure to give the service to users like ourselves. But in order for them to do that, they have to get service from tier 2 service providers, which in turn gets the service again from tier 1 service providers. So your communication end-to-end passes through different tiers of service provider until it goes all the way to the end. Okay, so this hierarchical architecture makes the internet more scalable. It's not that we claim that we can support unlimited number of users on the internet without affecting the performance. We cannot make such claim. It's not feasible. We always have limitation in the number of users, but again, This allows you to expand the infrastructure on the tier 1 without affecting the tier 2 service providers, and so on. So by expanding the infrastructure of tier 1, now we can support more tier 2 service providers. But the existing service providers will not be affected that much. Okay, but again, we still have some limitation. Okay, طيب. Quality of service is one of the very important ingredients to make a concept like the converged networks possible. Remember, we talked about converged networks when we said that we can support diverse set of applications and diverse set of user requirements on the same network infrastructure. Well, quality of service is one of the basic ingredients to make this happen. Quality of service talks about discriminating the traffic that is coming to the network based on certain characteristics. So I can discriminate video from audio. I can discriminate audio from text. I can discriminate the traffic that is coming from a particular user who paid more, okay, and give him better treatment. So this way, I give each type of application or user the quality of service that they expect. Okay? So this allows me again to use the network resources efficiently. Because if a user pays less, okay, and gets less quality, he will still be happy, right? Because he knows that, he or she knows that he paid less. It's like exactly when we get to the airport after coming from the summer vacation, and you have someone who tells you, you know, if you are a GCC, go here. If you are whatever, if you are a family, go here. So you have priorities. Same thing. Our network will now discriminate between, but discriminate here from the good sense, not discriminate from the bad sense. Because again, if I give each user the quality of service that they expect based on what they paid, they will be happy, right? So I have priorities amongst the different types of traffic. This traffic is video, so I should give it more priority. This traffic is audio, so I should give it the second priority. This traffic is just web browsing, so I can give it the lowest priority and so on. Okay? So it's all about discriminating between the different types of traffic. And that allows us to use the network infrastructure in a lot more efficient way. Because then the resources of the network is going to be used to provide exactly the demand or the expectation that the user expects. Not more and not less. So I can tailor and adjust my network resources efficiently. Okay? So I can discriminate between time-sensitive applications and non-time-sensitive applications. Loss-sensitive applications and non-loss-sensitive applications, and so on. Okay? Security, of course, is a very critical issue. In all countries worldwide now is becoming more and more critical. And when we study security, we see that we need to have a holistic approach when it comes to security. We have to cover security on all levels. So we need our information to be stored in a secured way. We need the access to our information on the servers to be accessed only by authenticated person, by identifiable person. Some of the information may be confidential, some of the information may not be confidential. So the amount of confidentiality in this information dictates what type of user who should access this information. That's on the information side. On the network side, we need the traffic that is coming to our network to be secure, to be legitimate. We don't want hacking to our servers or our machines. Our network devices need also to be secured in the sense that I don't want someone to hack into the router or the switch, because if that happens, guess what? Our traffic will go in a different way. It may be dropped completely, in which case the network will not be usable. So by hacking the network devices, that's a huge impact. Okay? So it doesn't affect one single user. It affects multiple users. So we need our network devices to be secure. We need the traffic that is coming to our network to be secure. We need our information to be exchanged in a secure way. We need to protect our information that's even stored on the server. So there are different levels when it comes to security that need to be taken into consideration. It's not one level versus the other. We have to support security on all levels. Okay, that's why security is a very, very critical issue worldwide. Okay? Type. So changing the network environment, so talks about the fact that there are some trends that appeared in the last decade or two that puts a huge amount of implication on the network design. One of them is bring your own device. What does that mean? So we need to talk about what that means. Online collaboration is becoming more and more widely usable. So we have now Facebook and Twitter, and we have telepresence, and we have Skype, and we have all these collaboration tools that are becoming more and more diverse, okay? And they have more and more features and capabilities that allows us to, as group of people or as population, to collaborate together, to exchange information together. Video. What is the implication of video on the network? Because video is again becoming more and more widely available, not only on YouTube. Even our TV at home is using the internet now. Whoever amongst you who use Mosaic or something like this. This is a type of video service that uses the TV to transfer the video over the internet. But again, because of the existence of quality of service, that's possible. So in the past, before quality of service, our network cannot support or cannot discriminate between the types of traffic. Now with the quality of service, we can have TV service on the internet, and we can have voice calls through WhatsApp or whatnot on the internet. Okay, not only like we have telephone lines for this, and no, we can use different services that in the past they were not possible. Now they are more and more feasible. Okay, and last but not least, cloud computing. That's a major disruptive technology that came about in the last decade and is becoming very, very critical. So there's a concept of bring your own device. Talks about the fact that the content on the internet needs to tailor itself automatically to the type of device that it's used on. It's like what we mentioned last time. I told you, you can do your exam on your laptop, on your cell phone, or whatever device. Just bring your own device, and you're going to be able to do, or you're going to be able to use the exact same application. If you log on to MyQU using your laptop, you're going to see the screen with the content look in a certain way. If you use your cell phone on the exact same website, the content will tailor itself and will give you another look and feel that's suitable for that type of device. Right? So you will see the same content but in a different look and feel. So that has some certain implications on the network, because on the laptop, you need to see a huge amount of content on one page. So because the screen is large and you need to see large content. Okay, so you need to have large amount of content available to laptops versus, for example, cell phone. You need to browse through the same content but in a different way. So maybe that has different implication on the network, because the amount of content that you see on one screen is less. So the amount of information that you may exchange on the network in that case is less. It's the same content, but you see it in a different way. So now your content needs to be flexible in that sense. That's one of the trends that makes our application usable on large set of devices seamlessly. Online collaboration, again, is becoming more and more diverse. We have telepresence, we have video conferencing. Well, video conferencing existed for quite some time, but now we have a lot more sophisticated collaboration tools, and even WhatsApp is becoming usable in terms of voice calls, and so you can support more and more features on these collaboration tools that make our communication seamless, facilitates the communication between group of people in a seamless way. Video has been identified in the last decades as the killer application for the internet. It's by far the killer application. What does that mean? This means that If we get to a tier 1 service provider, imagine yourself like you get to a tier 1 service provider and you have a very fat pipe, the traffic that is coming to the tier 1 service provider. You open that pipe and you try to classify the different traffic. You will see that the video traffic is consuming around 80 to 90% of the internet bandwidth. So it's by far the killer application. And this is becoming worse and worse because now we have high definition TV.
We have live streaming.
We have live streaming. We have high definition. We have 4K monitors. So again, this has certain implications on the network that it makes video more and more widely usable, and that puts certain challenges on the network in terms of, we need large bandwidths and so on. Okay, so this is the trend of evolving the video throughout the years, and we can see that video traffic is growing exponentially throughout the years, and that's due to the widespread of video-based applications, whether YouTube, whether our TVs, whether we exchange videos over the phone, we have FaceTime, we have, and so on and so forth. Okay. Cloud computing. That's the trend. So cloud computing talks about that any computing device can be grouped together and become virtually one humongous machine. To understand this, we go a while back when we used to have less resources on our old laptops or workstations. So what happens if you need more capabilities? You throw your computer away and you buy another laptop or another workstation with higher capabilities, right? So because we are attaching ourselves to the physical machine. Cloud computing talks about detaching our computing needs from the physical infrastructure. Completely. So we can group multiple physical machines, okay, and show it to a user as virtually one humongous machine. So we can bring our old machines at home, the ones that we throw away a few years back, connect them all together. Using the concept of cloud computing, they become one humongous machine that nowadays we can use as one humongous machine. So using this concept, for example, I can offer my physical infrastructure as a service to others. So now it's very common that anyone who wants to open a startup, they could have no hardware in this company. They have no hardware. They can establish a startup at home, okay, and have no hardware whatsoever. Maybe you use his laptop and that's it. So where does he or she host his applications and his data and stuff? On Dropbox, on Google Drive, and so on, right? Not only that, we can expand this definition to any computing needs. So I can log on to Amazon Cloud now and submit a request. I need a virtual machine with 10 terabytes of hard drive and CPU so-and-so and memory so-and-so and so on. Okay? And Amazon, they get this request. They tell you, okay, we will create a virtual machine for you exactly like what you asked for, and you pay for that, let's say, like $10 per month during the period that you need it for. And you as user, you don't care what is the physical composition of this virtual machine. Maybe what Amazon does is that they have, very small physical hard drives that they will connect and aggregate it together in a virtual way and present it to you as 100 terabyte hard drive. Okay? So it's everything is virtual. Everything is becoming like a virtual machine. I can submit a request on Amazon. We have a cloud facility here in the university. So if you have any project needs and stuff and you need some computing demands, So you can submit a request to ITS. I need this virtual machine for this period of time, and I need it to have this amount of storage, this amount of RAM, and this amount of CPU speed, and so on. What this cloud computing is going to give you is that it will integrate multiple physical machines, which you don't see. You don't actually interface with these machines in any way. For you, it's just virtually one virtual huge machine. For storage, for speed, for processing, for anything. Okay? So I can open a startup next day and have no hardware. Submit a request on Amazon, get virtual machine, store my information. Even my application can be expanded depending on my needs. So now I have a certain application. This is a new application that is used currently by 100 users. So I make some prediction, 100 users, I need this amount of storage, this amount of CPU speed and stuff. So I submit the request to Amazon, they give me this virtual machine. You pay maybe $3 per month. All of a sudden, my user pool has become 1 million users. Now I have 1 million users. I can submit another request to Amazon, and all of a sudden, I have now a virtual machine with 100 terabytes and stuff like that. And instead of paying $3 per month, now I pay myself $100 per month. That's it. I don't have any physical hardware. So that's the beauty of this technology now, that everything is becoming virtual, and depending on the user needs, you build a virtual machine for the duration that you want with the requirements that you ask for, and then after that, everything will be dismantled, and I can create another virtual machine to another user using the exact same physical infrastructure. Okay? So that creates ultimate flexibility and agility especially to new businesses. Anyone can now open a business at home. Develop an application, post it on the cloud, make it available to people. Very easy. Okay? After some time, the user pool is growing. You can pay more to get a bigger virtual machine, and that's it. But you don't have any physical machine in your company. Okay? Dropbox is an excellent example to this. Google Drive, OneDrive, YouTube, all of them, they use cloud in one way or another. Any computing needs or computing machines can leverage this concept. Another technology trend that is becoming more and more focused on now is what we call smart home. Smart home talks about the fact that our appliances at home need to be smart in such a way that maximizes our experience. So I need to get to my house, and all of a sudden the lights will turn on in the same level that I want or I prefer. I sit on the couch, and somehow the house will recognize that I need to watch the TV, so the TV opens on the channel that I prefer. I need to have my fridge adjust itself automatically to the weather that is currently happening. So if it's hot, the fridge will be higher, if it's low, and so on. But also I need to lower my electricity bill. So I need to have good experience, but less cost on the energy bill. So, which means I can use, for example, solar cells to power my house as much as possible. So this puts an implication on all the devices in my house that they have to be smart. They have to, which is what we call Internet of Things. Okay, everything is going to be. It's going to have an IP address, it's going to be a device on the internet, and therefore it's going to have some level of smartness. It needs to be capable of processing some information. I need to ask this device to do certain things at certain time. All this intelligence and smartness is going to be on the cloud. So the cloud itself will have this intelligence, will have these sophisticated algorithms, and it will send some actions to my appliances at home, okay, to control my appliances, to maximize my experience as a user, but at the same time lower my electricity bill. For example, if I get outside the room, I need the lights to turn off automatically. I don't need to, even if I don't turn it off. Even the level of intensity of the light needs to be adjusted based on my preference. So this way, I can lower the electricity bill. So that's what a smart home is all about. This is a multi-billion-dollar industry, which is really one of the biggest trends that people are working on nowadays and in the next few decades. And again, this has significant implications on the network and communication and stuff, as we can imagine. So anything needs to be smart. Okay, so we talked about ADSL. We said that the idea of ADSL is just the fact that we have telephone lines in place. We used to have telephone lines in place, so we might as well use it for communication. So we invented ADSL as a technology to provide data communication over telephone lines, right? Same idea here. We have already power lines in place. All our rooms and stuff are powered with power lines. Well, power lines is more challenging because they have high voltage, right? We have 220 volts. So the question is, can we use these heavy power lines for communication as well? And the answer is yes. Using power line networking, now it's becoming feasible to exchange information on the same lines that feeds us with electricity. Okay, so this is the new technology. This is the new trend. What is the benefit of this? Well, in our house, imagine if we have like a multi-story house. To have communication across the multi-story, we can use Wi-Fi, but Wi-Fi has limited range. What is the other alternative? We can dig some Ethernet wires, but again, setting up these wires across multi-stories may not be an easy job, right? But using power lines are already there. They are part of the structure of the house. So I can use the power lines to have communication across the multi-story, in a multi-story building or a house or something like this, without really having any specific deployment. But again, this requires, of course, the fact that you have to deploy certain devices similar to what we did for ADSL. We need to have devices that fuses the electricity and information and have them to go through the same line, and on the other side diffuse or expand the electricity to go to the appliances and information to go to my computers. Okay, so again, using this technology, I can have information exchange and data communication across the power lines. We're talking about these trends, of course, on a very high level. These are very sophisticated, and the standards for this is very complicated. I will not go through it in our course, but this is just to give you some idea that there are some new trends in the last few years that put a lot of challenges and implications on the network design. And that's why we need network designers, because it's becoming more and more complicated. Wireless broadband, well, wireless broadband uses the cell towers, the base station towers. These are huge towers. But when it comes to communication in our houses, we tend to use what? Wireless Wi-Fi. So what will happen is that for communicating between the devices in our house, we use Wi-Fi, but our cell phones, they use the cell towers somehow, right? So the trend is again to try to converge this network into using wireless broadband communication even inside our houses. So what is the implication of this? We need to have small scale of these base station towers in our houses. And if that happens, we can use the same cellular technology all the way. In some cases, we don't even need Wi-Fi. What is the implication of this? Is that all our computers and our cell phones and everything is going to use the same technology to reach to the wireless broadband service providers. We may not need actually fiber optics. We may not need ADSL in that case, or in some cases we do, but we use the same technology all the way. We use wireless cellular technologies all the way. The benefit of this is that, again, we use one seamless technology all the way. On the other side, again, cellular technologies tend to have bigger range. So that's why our cell phones can communicate to very far base stations across very large range, very large distances. Well, our devices at home may benefit from this, is that we can have communication across multi-story in a very high range, and we can have reliable communication. So broadband cellular technology is getting into our houses. That's what we're trying to say here. There are special devices that we can set up at home that can make cellular technologies available inside our houses. And then all our devices are going to use cellular technology instead of using Wi-Fi on one side, Bluetooth on one side, ADSL on one side. Everything is going to be on the same infrastructure. So our network, again, is conversion into the same, using the same infrastructure and using less number of technologies as much as possible. Although our demands and requirements are getting more and more diverse. That's why the network design needs to be done very efficiently, very carefully, and we need network designers to design these types of technologies and networks. Last but not least, as well, we talked about security. So we need to secure the traffic that is coming to our network. We need to secure the workstations, the information that they store, the information that they exchange. So Ethernet needs to be secure. Our switches needs to be secure. Our routers needs to be secure. And our information stored on these machines needs to be secure. And there's different techniques that are required to apply or to support security on each of these levels. That's why security is a huge, huge issue, and that's why it's one of the grand challenges of Qatar now. Cybersecurity. Cybersecurity is one of the grand challenges in Qatar, and in the region, and the world, really, because of the threats that are becoming more and more widely spread over the internet. So, to summarize what we have talked about in this chapter, we talked about networks and the internet. We talked about the different sizes of networks. We talked about small networks or local area network. We talked about wide area network and how they are networked together. We talked about the categorization of networks, not from the geographical sense, but from the logical sense, which is what we call the intranet and extranet. We also talked about the different features that need to be in place in order to say that our networks are efficient in terms of supporting communication, like, as we said, fault tolerance, like scalability, like security. These are very important features. And what are the implications of new trends, like bring your own device, like cloud computing, like online collaboration, and so on the network design. One thing to say here is that, remember, we covered so many things in this chapter. There is no way that I expect you to know everything about these technologies, because each of them requires a course on itself. And that's the approach of Cisco, is that at the beginning they give you the whole picture, but the whole picture is going to be blurry, and it's going to be vague a little bit. And what happens is that in later chapters you will notice that some of these pictures will be spotlighted, which means that part of this picture will become clearer and clearer, until the whole picture will become relatively clear and sharp. And even by the end of this course, you will not be able to cover the whole picture. You have to have another course which will give you more depth in each of these parts. Okay?